Okay, this will actually be probably the fourth problem on the quiz tomorrow. We have, and this was from page 39, I believe. So we have the radius of a circle is 9. Radius is 9. The arc has length 22. So the arc has length 22. I'm not sure how that looks on here, but I'll just go to my ugly spot right here, my circle. Okay, and it says find the length of the chord PQ. So this is PQ. Or the length of that chord. Okay, the whole goal here is to understand and use radian mode. So first thing I did is I went ahead and if I cut that isosceles triangle in half, okay, now what's the length of the arc it intercepts right here? 11. I cut it in half, so that's 11. Okay, now the goal here is I want this side. So what I'm going to do is try to find that side. And since I cut it in half, each one of those is equal to x. Okay, if I had this central angle right here, I could just use a trig function. And actually it would be, let's see, opposite hypotenuse. I would use a sine. Okay, but I don't have that angle in terms of degrees. But we can do this in radians. So if I look at this sector right here, that's the radius. This is the length. So how would I figure out how many radians this arc is? 11 over 9. So that arc is 11 over 9 radians. Okay? And that means that this angle, the central angle here, is also 11 over 9 radians. Now, you could do a direct transfer from radians into degrees and solve on your calculator, but your calculator will let you do radians. So what I would do is make sure I'm in radian mode. And I want to solve for x, so I would do sine of 11 over 9, every degree, equals x over 9. Multiply both sides by 9. So I get x equals 9 sine of 11 over 9 in radians. Now that's x. So how would I find the length of the whole chord then? Just double it. So chord PQ equals 2 times 9 sine 11 over 9. Make sure you're in radian mode. Yeah, Emily.
Why couldn't you have just done 9 over 22 and solved it that way? Why did you have to split it?
9 over 22.
Yeah, because you split it in half and used 11.
Yeah, you could have done 22 over 9, you mean?
Yeah.
Yeah, if you do 22 over 9, you'll get this whole angle and cut that in half.
Why would you have to cut it in half?
Because we're using trig functions here, and since we're using trig functions, we have to have a right triangle, and this triangle right here is not a right triangle. So we had to form a right triangle by cutting it in half. Okay? Anybody do that on a calculator? Or you could have used law of cosines. Yes.
I got 16.917.
I will go with that. Both those ideas work. All right, this problem is kind of our introduction into getting into exponential equations and graphs. Okay, they gave us an equation. And they actually told us that our equation, which is right here, is the picture to the right. So we're just answering some simple questions about the equation. What does P of 0 mean? What is P of 0?
No cut with the current population.
The population when?
The current time.
At time 0 to start, right? So if I look at my graph, That's right here. Looking at my equation, what was my starting population? 5,280. So P of 0 equals 5,280. And Conrad already said that is the population at time 0, or your starting population. All right, B. Use the graph to estimate the solution of the equation P of t equals 10, 5, 60. And we kind of did this on the previous problem, on number 5. So 10, 5, 60. So here is 10. And are these going by thousands? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you're going by thousands. So 10, 5, 60 is like right in there. So what was our estimation there? Yeah, 10, 20, 30, about 29.
Yep.
And we had done that in the previous problem. We got 29 point something years. So we'll just put approximately 29. And I don't have to put years, but because it's just asking for the graph, on the graph. All right, C, calculate P of negative 30. P of negative 30. So I can substitute a negative 30 in there. 5,280 times 1.024 up to the negative 30. And what's the answer to that? Jacob, did you get that?
2,592.
2,592. And what does that represent?
That would be the population 30 years ago.
Yes, population 30 years ago. Assuming it had the same growth rate, population 30 years from now ago.
Wait, question.
Yes.
So if it was positive 30, it would be population from 30 years from now?
Yes, population 30 years from now. Again, assuming the same growth rate. Population grows at an exponential rate typically. So that's what we're looking at. All right, D, comment on the part of the graph that lies outside the borders of the illustration. How would it look if you could see it, and what does it mean? So basically, it's just saying that what is the graph going to continue to do? Go upward. So I would just say graph's going to start, if that's our axis, then it's going to start pretty flat. Woo, went all through everything. But it starts to increase pretty quickly. If you think about it, population at some point started at a really small number. You know, towns started at 5 people. You know, then somebody moved in, 10 people. All right, and then eventually it started to grow and grow. All right, bonus question for the quiz tomorrow, and it wasn't in your homework, is write the exponential equation for the graph below. Okay, so first step, understand what we're asking you to do. We're asking you to write something in the form of y equals a times b up to the x power. That is your general exponential equation. Okay? We've already looked at some graphs of it, and we just haven't explicitly said what each of these means. But I think you guys pretty much have it. What do you think a should be according to this graph? 8 is correct.
Oh, cool.
So this is your start. This was our starting population on the last problem, right? And that's our starting point. It's our y-intercept. So that is correct. Y equals 8 times something to the x power. Now, what was that something we typically had in parentheses? A percent of growth, right? So we want some percent of growth here. How would I find a percent of growth using these points?
Would be
8.32. Would you say, Kyle?
you divided by 8.
Divided by 8. That'll give you a percent of growth after the first year. We're going by ones, so we're perfect here. I gave you a nice point, that's 1, and I'll do that in the test too. And what'd you get your percent of growth to be?
1.04.
1.04. So that would be a 4% growth, but it's an increase of 1.04
Why would you divide it by 8?
because you're seeing what the growth was from here to here.
Oh, okay.
So you're just taking and dividing the y's because it's 1. Okay, so 1.04 to the x power. That's your answer.
That's it?
That's it.
That's really easy.
And it should be pretty easy.
Right, 1 instead of x because it's been 1 year.
No, we want the equation of the whole line, the whole graph. So now if we wanted 10 years on that graph, we could substitute a 10 in there.
Yeah.